The last type of test I want to show you is architecture tests. Architecture tests allow you to enforce your software architecture rules and your software design rules by writing simple automated tests. There are a few libraries that you can use to write architecture tests, and I will show you how to implement these types of tests using one of those libraries, but I also wanted to mention why I think architecture tests are valuable, especially inside of the clean architecture. As you know, clean architecture is a prescriptive architecture, and there are a few components or layers inside of the architecture: the domain layer, application layer, which together form the application core, and the infrastructure and presentation layers. The clean architecture enforces some rules as to which layers are allowed to reference the other layers in the architecture, and in simple terms, the outer layers of the architecture are allowed to reference the inner layers, while the inner layers are not allowed to reference the outer layers. But I'm going to show you how we can enforce this using architecture tests. So let's start by installing the library that we can use to write architecture tests. I'm going to browse for netarchtest, and I will install the netarchtest rules library. Now that our NuGet package is installed, I'm going to add a small piece of boilerplate code in the infrastructure project, and I'm going to add a class that I will call base test. I'm going to make this a public and abstract class, and inside of this class, we're going to add a few fields that will represent the assemblies pointing to my different layers or projects in the solution. So we're going to have the domain assembly, the application assembly, the infrastructure assembly, and the presentation assembly. Let me add a reference to the Bookify API project so that we can actually import the using statements for the classes that we require here. And now our base test class will compile. And now we are ready to write our first architecture test. So I'm going to create a layers folder, and inside of it I'm going to add a new class that I will call layer tests. Inside of this class I'm going to enforce the direction of dependencies in the clean architecture for our clean architecture layers. So let's implement the base test class, and I'm going to add our first test case. The architecture rule that I want to enforce is that the domain layer should not have a dependency on the application layer. And how the netarchtest rules library allows me to do this is by giving me a way to find the types inside of the domain assembly, and then I can use the Fluent syntax to express my architectural rule. So I want to say that the types in the domain assembly should not have a dependency on the application assembly, and we're going to take the application assembly name. I'm going to call getResult after I have written my rule, and this is going to give me back a test result object, and I can check if this test result is successful or not. So let's go ahead and quickly run our architecture test. So let's run the layer tests, and you can see that our first test case is green. Let me add one more test case. This time I'm checking that the domain layer does not have a dependency on the infrastructure layer. And in a similar fashion, I'm going to add the remaining test cases. So I'm going to verify that the application layer doesn't have a dependency on the infrastructure layer. I will also check that the application layer doesn't reference the presentation layer, and I'm also checking that the infrastructure layer isn't allowed to reference the presentation layer. And now I'm going to run the 5 architecture tests that I defined, and you can see that all of the tests are passing. So architecture tests give you a very simple mechanism to enforce your software architecture rules, and in this example I'm enforcing the clean architecture rules and the direction of dependencies between the individual layers. Other than the layer tests, you can also write some architecture tests to enforce design rules for the various components in your system. So I'm going to add a domain tests class, and I will walk you through the test cases that I have inside. One example of what you could test in the domain layer is that the domain events should be sealed types. You can achieve this by scanning the domain assembly and looking for types that implement the iDomain event interface. Then you can write a rule that all of these types should be sealed, and you simply call getResult, and you verify that the test result is successful. So this test is enforcing a design rule. You can also enforce naming conventions. So I'm writing a similar test, scanning the types in the domain assembly. These types have to implement the iDomain event interface, and I'm verifying that these types should have a name ending with domain event. So in this instance, I'm enforcing a naming convention using my architecture tests. And the remaining test that I have is an interesting one. This test is checking that my entities should have a private parameterless constructor. An example example of why this could be useful is if you are using EF Core as your object relational mapper. EF Core can sometimes have problems with domain-driven design entities because they have private constructors. But if you create a private parameterless constructor inside of your entity types, then EF Core will have no problems. So let's run our domain tests and see if they are all passing. So our tests complete, and you can see that all of them are green. So now I'm going to try to break my tests. I will go to an implementation of the iDomain event class. And for example, let's make the booking cancel domain event non-sealed. Then I will find another implementation, for example, the booking completed domain event, and let's rename it to booking completed event to break the naming convention that I'm enforcing with the architecture tests. And lastly, I'm going to look for an implementation of the entity class, for example, the user, and let's remove the private parameterless constructor. And now I'm going to run my domain tests again, and you will see that all of them are going to fail. The test checking for private parameterless constructors can also tell you which type caused the test to fail, and in this case it's the user. So if I revert back my changes, make the domain event sealed again, and rename this to booking completed domain event, and now I rerun my domain tests, I'm expecting all of them to now be passing, and you can see that this is the case. Now I'm going to show you a few tests that you could write for your application layer, and I'm going to add the application test class, and let me walk you through what I have inside of this class. The first test case I have enforces a naming convention for any types that implement the iCommand handler interface. I'm expecting them to have a name ending with command handler. The next architecture test is also checking my command handlers, and it's verifying that the command handlers are not public. And this is because I want my command handlers to be internal. Moreover, I want them to be internal and sealed, and I could also enforce this using architecture tests. Then I have a similar type of test for my query handler implementations. I'm checking for a naming convention that the name of these types ends with query handler. I'm also making sure that the types implementing iQuery handler are not public types. And then we have the same set of tests for our abstract validator, which is a type from the Fluent validation library. So let's go ahead and run our application architecture tests, and let's see if all of them are going to pass. You can see that one test has failed, and this is our check that the implementations of the abstract validator class are not public. And if I look for the types implementing this class in my solution, there is the register user command validator, which is an internal and sealed type. So it must be the other one, which is the reserve booking command validator. So let's make this an internal and sealed class. And if I rerun this test, I'm expecting it to now pass. And you can see that our architecture test is now green. Architecture tests have become a standard on my projects because they are very easy to write, and I can reuse most of the rules between different projects because I have similar conventions that I want to enforce. There could be some differences. For example, in one project I want to use the clean architecture, so I will have a specific set of layer tests that I want to enforce, and in another project I could be using the vertical slice architecture, which has a completely different way of structuring a solution. But overall, I am satisfied with the value that architecture tests bring to a project, and this is why I use them, and I'm hopeful that the examples I showed you inside of this lesson will motivate you to start using architecture tests in your own projects.